we talk about the L476 RG, so you can also go to your IDE and then you can create a new project and select the board. And then these are the things. I think you had already done this, so I am not repeating this. So here you can see prescaler value. The prescaler value you can change as you want. So in the L476, the maximum clock speed is 80 megahertz. So that is what you are seeing here. That is the 80. So if you set up the 80 and then the prescaler value is 1, the system clock is 80. So everything is in the default mode here. And you can change the APB2. So APB2 here, you can change the APB2 value and observe the timer multiplier value is also changing. So whenever you change this one, so here this value will also change. So when you change the prescaler value, then this value will change. So manually we used some kind of formula, but of course in the program you don't need to do that manual calculation. Everything will be done automatically. So if you apply the formula and you can check if this one is correct or not. So now I changed APB to 16. So you can change whatever the values you want. You can explore and configure this prescaler value more. For now, I just keep this APB2 as 1. APB2 value as 1. Same as the default value. So now you go to the pinout and configuration tab. So pinout and configuration tab, what can we do here? So you can activate the 16-bit timer. For example, here, as I said, like under the timers, there are so many timers peripheral available in the L476, and we are going to use only the 16-bit timer in this example. So you just enable this one. And in the drop-down menu, yeah, for channel 1, you can see various hardware connections that you can make it to work with timer 16. Yes, it's possible. For example, input capture allows. So yes, you can enable or disable so many options based on your timer selections. And for once you set up this, it requires a specific pin to use, but it's very helpful to have the hardware control. So I think these things can be explored once you start this setting up by yourself. So I think I'm not sure I should go through these steps, but we will see. Now we will change the prescaler value. You can set up this prescaler value. So you are in this timer, and then here under this configuration, you will be in this page. So here you can see here this prescaler value. Of course, you can change this if you want, but here I keep this default value 80 to 1. And you can also set up the prescaler. It means the prescaler value is 1. So then it will automatically take 1 increment as prescaler of 2. So it means like it will just count 1 by 1. And if you set the prescaler value is equal to 2, then the counting will be increasing for every 2 internal clock signals. So in this example, yeah, so if I enter 80 minus 1, then it means it will take 79 megahertz as the maximum value. So this is in the up counter mode. You can see here counter mode is up, and the counter period, so that is automatically it takes to the maximum value for 16-bit counter. That is, you can see 2 to the power 16 is equal to 65,535. It's taking by itself. So since I put the -1 here instead of 65,536, and it's taking 65,535 because we are starting from 0 up to this number. And the F clock, that is the 80 megahertz. Prescaler is also 80, so the timer runs at 1 megahertz clock speed, 80 divided by 80. So the formula is N, where is the pen? The formula is N divided by F timer clock or sys clock. So here we have both, we set up 80 and 80. So that is going to be 1. So there is going to be 1 megahertz. So it means 1 tick for every microsecond. The counter, the register value will change for every single clock cycle. So we can easily estimate this counter can count maximum 65,535 levels. After that, it will go to the overflow and it will become 0, 0, 0. All the 16 registers will become 0. And you can also count the overflow time period. So based on the formula, so once you have this one, then you have the number of the levels, that is the 65,000. So 1 multiplied by this 65,535. So that is what giving here 65,000. So we can simply say this as a 65 milliseconds. Yep. So everything is just like the same formula. So other details here we can leave as default value. So internal clock division helps to adjust the deglitching filters or RCR. So these are, we don't need to touch. We can just keep this RCR repetition counter as 0. So then now we will move on. Now you can generate the C code. So this is very simple to set up the timer. So just to go to the timer, you enable this timer and these values are like this. It will be normally, it will be 79 or 80 megahertz. You are just making up to 79 or 80 minus 1, or you can also keep it as 80, and everything else is default. And once you generate the C code, then you can just explore the C code by yourself. So we are including the header files. And yes, so here I think I did some mistake. Yeah. So here, once after I generate the C code in the header file, I spelled wrongly, so I got an error. So you watch out when you include the header file. So it's supposed to be, it's not a studio.h, it's a stdio. You know, this is stdio.h. What is this mean? This means standard input output header file. So in each program you are including header file. If I am going to do more mathematical operation, then I can include math.h. So it's up to the program where you are going to use, then you can include the corresponding header library. So here by mistake I put stu studio.h. So when I execute the program, I got errors. So I needed to correct the errors. So the correct one is stdio.h. So, and then you can just go and explore these programs. This is a very simple one. And if you watch the DigiKey video under the timer, they had also given this in step by step very clearly. So you can explore the timer by using that reference video. This timer. So if you have a serial terminal program together with Cube IDE, then you will see the timer function in your terminal. So I also mentioned about the serial terminal program. You can use either PuTTY or Hercules. You can install and you can see how the timer is counting in your PC. In your PC, you will open this serial terminal program, STP, and then here you can see the counter, how it's counting. Yes, there are so many these STP. You can use whatever the one it suits for you. Segar, ST-Link or J-Link. So I recommend you to use PuTTY or Hercules. Yeah, these are the two hardware that is available in the lab, which you need for your assignments 2 and 3.